Welcome to this in-depth session about point clouds. I'm Xian and I will be introducing you some point cloud features in BricsCAD, mainly also introducing you the new V21 features for point clouds. So we base our development on three principles for point clouds, mainly performance, 3D and 2D. So let's start with the first point, performance, which is point cloud attach. So point cloud attach, if I open the command, you will see I will have the choice between file or folder. So I can actually also import multiple files at once. So if I do that and I have this dialog right here, you'll see for example, this I want to import. You will see that we also support the most popular file formats, which are E75, .les, PTS, PTX, RCP, and RCS. So let's choose this Office point cloud right here, an E75 file, and open it. So you see an input for units, so just give it meters, for example, and click OK. So now this point cloud will pre-process in the background, so actually you can still do navigation and other edits while this point cloud is pre-processing. So it's partly multi-threaded, so in that way the import is also much faster compared to V20. What else? Alright, so let's see. In the meantime, I will also open settings, so you can see here that after it's loaded, the pre-processed point clouds will be stored in a cache folder. So let's open that. So you see here in this path right here, it will be stored in this folder. In the meantime, you'll see here that my point cloud is pre-processed. So let's see how it goes. So here's my point cloud. So this will be saved in my folder that I just showed you. This is by default a support folder, but in my case I also have an external drive for it. But let's take a look at our point cloud right here. So that looks pretty good. Of course, if I now open another file, for example, and hit point cloud reference, here are actually all the pre-processed point clouds that I have in my hard drive. So for example, I can choose another one which is larger, 100 gigabytes, and if I click OK, you will see that it will be much faster imported in my BricsCAD. So like this, I will have quickly my bigger point clouds as well. If I want to delete this in my cache, that's also possible. So point clouds delete cache. Delete item. So you can choose again from my cache folder right here, and then, for example, delete this office again like this. All right. Next part, let's see what we can do as in edits for point clouds. Right here, let's switch to top view, and in BricsCAD, of course, you can select this point cloud and, for example, rotate it to be more aligned with the X and Y axis, but we can also do it automatically with align. So if we do that and just select the front part right here, and now it will be calculating the rotation angle. So in the meantime, this is also a background process, so I can still hover around and click on some things on edit while the command is loading, if you see in the taskbar. All right, so this is done, and you will see now my building is aligned with the X and Y axis. Now, the next thing that we would like to do is point cloud crop. Point cloud crop, what does it do? So it basically, you can choose a selection where you can crop your building into, inside or outside. You have the choice to do that, and like this, you will be clipping more of a specific region of your point clouds. Of course, these points surrounding this building, it will be not deleted. They will be just hidden, and if you uncrop it you will see them again, but right here it will be easier for you if you use other point cloud features. It will only take in account of what you see on the screen, so the processing will be much faster if you crop a certain part of your point cloud. Let's take a look at the different ways that we actually display points in BricsCAD. We actually have 3 options for that, 3 commands that we can use to display those points, because points don't only have a visual representation, but it also contains a lot of information, as in the color or the scan position of a certain point. So let's take a look at those 3 commands that we can do to display it in BricsCAD. The first one here is point cloud point max. So currently, if I look at the commands, it will display 400,000, meaning that there will be only maximum 400,000 points in my drawing. Let's change that to, for example, 5 million. You will see that the number of points are increased by a lot, so like that you can have a more detailed point cloud. Now you see there are still a lot of gaps in between this drawing. An example to increase the points, you can actually go ahead and increase each point of these point cloud points to make it more of a visual representation in the drawing. Like that you can go ahead and decrease the points again if you want to see it more in an X-ray version. Alright, now let's change the adaptive view as well. So currently, if I check the point cloud adaptive display, it's on 0, meaning that the points will be just fixed in a way. But if I you will see, if I check this on, this display will be adapted to the zoom and to the certain zoom level that I'm in. Let me just switch back to a little bit less of a point size. Alright, so now you see, instead of the gaps in between that you always see, the adaptive view will adapt to the zoom level, and also if the point clouds, certain points are more, or certain places they have less points, these will be also filled in for you, so you don't see as many gaps as if the adaptive view is off. So like that, if you zoom around, you will see a full point cloud without having empty parts in it as well. Alright, so this is a very useful and a very nice way to display your point clouds. Next up is the bubble view. The bubble view, these are actually these spheres that you see in front of my point cloud or in my point cloud. So these represent the scan positions in my point clouds, and these are also, during the pre-processing process, it's imported into BricsCAD. So like this you can view these bubble views. So if I click on that, you will see another dialog appearing representing the scan position of the scanner. Like this you can drag and scroll around the view, and this also has 3 visual representations that you can change with the tab key. So the first one was the RGB colors. Here are the normal vector views. So for example, here it's represented with the UCS colors. So for example, the blue ones here are perpendicular with the Z-axis, and then the green and the red one represent the X and the Y-axis as well. So the next one is the in-depth visual style with the grayscale, meaning which elements are further away or more near the scan position of this image right here. Alright, if I just click on and make it a little bit smaller, I also have Control A, which will automatically go to the model view. If I, for example, am in this position right here in front, if I Control A, you will see that in model view I will jump right to the view where my bubble viewer was. So like that I can quickly navigate throughout my point clouds. So the next part that I want to talk about is the snap option. So for now, in V21, we have added a new eSnap option called point cloud closest point. So this is a 3D snapping tool. So if I go to the 3D settings, you will see here that I have the option to point cloud closest point to snap to those closest points as well. So like that you can more easily snap to certain points of your point cloud if you, for example, work with some other solids in your model as well. Like this, there will be no confusion of what you're selecting. For example, like this, you will see that, oops, let me just navigate through. If I click on, for example, line, you will see that this blue X cursor right here is actually snapping to the closest point possible of your point cloud. So like this, it will be much more easy to work with point clouds with this option right here. Of course, you can turn it off if you don't like to have this snapping option. All right, so these were some basic tools that you can use in the Pro license. Now I will actually talk a little bit more in depth for the BIM functionalities that we can use with point clouds. The first one is detect floor. So of course, if you have a bigger point cloud with multiple floors like this one, or I have another example of a house here, for example, where I have different floors, and of course I can use the section command to do that, but in BIM we also have an automatic floor detect command for that, so you don't have to manually add this yourself in your point cloud. So this is a little bit different than the crop that I showed before, because the crop only will crop the point cloud itself, and now we're actually making sections, so the traditional BIM sections basically, that will also clip all the other elements in your drawing, so not only your point clouds. So now let's do that. So automatically detect the point cloud floors like this. You can choose for the full point cloud or a selection. So in this case, I'm just going to select this house right here. And now if I press enter, this is done. And I can zoom back into my house, and you will see now that there are some extra sections added, basically three section volumes. You can see here, here, and on the top part. So like this, you can double click on it and take a look inside your point cloud as well. Like this, it's easier to navigate throughout your point cloud using these clip volumes. Just click on and off to have a certain level displayed, and then you can work on it some more. All right, now let's go over to back to my bigger model right here. So here I also have added this floor detection. So here I have recognized 4 different levels, and let's start to make a model in base of my point cloud right here. So the first thing I want to show is actually automatically detect 3D geometry based on your point cloud, and like this I can generate geometry as in solids into my BricsCAD drawing and these solids I can actually use to classify and so on, and add more data to really create a BIM model out of it. So with that, of course, I can just trace it by using direct modeling tools and a polysolids tool, for example, to create these kind of walls and slabs. But in this case, I can actually use Point Cloud Fit Planner. There are two ways to do that, one in the bubble view that I just showed you, or one in the model view. So let me show you both. The first one in the bubble view. So if I, for example, click on this point right here, and I'm back at this bubble viewer, I can go ahead and launch this fit planner command. So if I have the bubble view open and I use this command, it will assume that you will do this fit planner command in this bubble viewer. If you have this off, then it will assume that you will detect it in model view. So if I now fit planner, you will see that I have a dedicated cursor right here with this red circle, and it will detect, for example, here the floor for me. So if I click on that, we will see it turned purple, and in the meantime, at the same time in model view, you will see that I've created a plane according to the point cloud floor that I've selected. Alright, so like this I can accept it. Let's do the same, for example, this wall here, and it will also detect the door opening, for example. So if I use the control key, you will see that I will have several options to choose from, but let's just accept this as it is. And for example, here for the walls, for the wall with the windows as well, if I zoom in here a little bit more, and I, for example, instead of the rectangular plane, just select contour, you will see that the holes for the windows are also detected and created right here. So if I click accept, instead of a full plane, I will have the window openings as well. Like this, I can go over the whole room to scan the different planes to create my room right here. Alright, so if I just close this off, you will see that right here I have actually really created the planner surface and so on in my drawing as well. So now let's try to do this fit planner again with in the model view. So let's choose a wall, for example, right here, and again use the same command, but instead of using the bubble view to choose the planes that I want, I can just go ahead and, for example, choose this wall. And it will take a little bit longer because it will actually scan the entire point cloud for this plane right here, and it will also take in account to, for example, the other surface on the other side to create really a wall, for example, as in a solid. So not only a plane, but you can actually create solids as well. If I click on the control key, you will see that I also have the option to make a solid as well. If I accept that, alright, you will see if I open up the command line, you will see a little bit of extra information on what kind of percentage, as in used points, did I create this plane, for example, so you have some feedback as in what kind of tolerance is used for creating this plane or this solid. These tolerances, you can actually go ahead and change it to a lower or a higher tolerance. If you click on the point cloud and in the properties panel, you will see that the plane fit tolerance is currently 0.03, but of course you can change it to a higher or lower tolerance. Lower tolerance, for example, will mean that it will detect less points, so it will probably detect less of a detailed kind of plane. For tolerance is higher, it will of course detect more, but probably also will load a little bit longer as well. So now we've created some planes and solids in our drawing, and we can go ahead and select our point cloud and hide it for a moment to see what we've actually created. So in this case, with the Bibble viewer, I've created these planes right here, and with in model view, I have created this one solid. Of course, once you've created these, you can, for example, still edit it with, in this case, connect. So these work on planes too, like this. So not only solids you can direct model, but like this you can also use connect for planes to clean up a little bit of the detected geometry. Alright, if I zoom in now and zoom out now and open the layers panel, I actually already have created the full building right here. And if I just show back my point clouds like this, you can actually trace over the whole building with this fit planner command and start creating 3D solids and start creating your BIM model like that. So this is just an example of what you can do with it. Another way to start creating your 3D model is with another BIM specific command for point clouds called project section. So let me do that to hide this one back, and for this instance I don't need it anymore, and show back my point clouds. Now what I'm now going to do is actually create a 2D generation out of one of these section volumes. With that, I'm going to use the point cloud projection section and select one of the volume sections, press enter, and you will have a new dialog open with some settings that you can do for the wall detection and the pixel size for the raster image of the point cloud that will be created for you. So let's go over to the options that you have. Of course, you can not detect the walls if you don't like to. If you just want the raster image, just check it off. In this case, I want to have it on to show you the different options. So for the search area, you can choose for the distance from plane or across volume. So for the distance from plane, only a search is in a limited zone, as in the wall distance, in this case the 0. So it will try to search for a kind of offset of your section. Compared to the volume, it will, across volume, it will go ahead and search and take in account all the points in your point cloud. So it will search for regions of points, and windows and doors and so on will be detected as well. So this is that. And then the gap tolerance, gaps smaller than a certain value, in this case 50 millimeters, will be closed. The angle tolerance is also for generated lines for these walls that has a smaller angular number. These will be merged, and then the minimum length for this lines that will be generated, so in this case can be 200 around. And then for the pixel size, so for the raster image that will be created as well, you can go ahead, in this case 10 millimeters, meaning that the pixel size for in model units of the generated raster image, so higher the pixel size, it will take longer to load, of course, and lower, it will be faster for you to generate this 2D drawing. Attachment for projection, you can do it in the same DWG or you can create a new one. In this case, I want to create a new one. Projection resolution, finest or adaptive. In this case, I would like to have it finest. And then lastly, the attachment points in place according to the existing point cloud, or I want to have it aligned with the X and Y axis. So like that, I can override old projects and old lines as well. So if I click OK, there will be another drawing opened, which is floor 0. So this is just a default title. Of course, you can change that. And you will see in the status bar, it's loading. So in the meantime, I can actually go ahead and do some other edits in other drawings as well, because this is also a background generation. So after the generation, you will see that I have some green lines. So these are the detected walls for my point cloud, and as well as a raster image. So this one representing the point cloud. So if I hide that for a moment, you will see only the lines. So like that, I can go ahead and, of course, start drafting, for example, your floor plan. Of course, we can also use some other tools to optimize this lines. So in this case, I'm going to use Optimize to just make some connections and merge some lines to make it a little bit more clean for to start creating a model out of it, for example. So if I click on Optimize, you will see that I'll also have some options right here. I can go ahead and choose the entire drawing and close the gaps. The tolerance, angle tolerance around 30 is okay. The distance, I can set it to 120 maybe. And then rounding tolerance, it's okay. And the gap tolerance, let's say 150, let's say a little bit less. All right, and then you will see that some lines will be more filled in and straightened out as well. Now that we have optimized our 2D lines, we can go ahead and start to create our 3D model out of it. An example is for that, for example, Quick Draw. So with that, you can actually go ahead and use Quick Draw and trace these lines to create and start creating your BIM model. So like that, I can create my first room according to the thicknesses of the lines that I just generated. Like this, I can start and hover over the full building to create my lines like this. So this is another way to kind of start your model starting from your point cloud. All right, another example for this point cloud projection is actually not really creating a building on top of your point clouds, but sometimes you just need the point clouds as a reference. For example, in this case, an older historical building as a point cloud, and you just want to implement a certain part into it. For example, here this elevator that I've added into this drawing. So this is an XREF, so a 3D model that I've inserted into this point cloud. So not necessarily I want to trace over the whole point cloud to create this church, but I actually just want to see how this elevator works within the point cloud. So like that, it's very handy to have this raster image at the background as well, to just have a reference of what you're actually doing with the certain model that you've implemented in that project. So like this, I can go ahead and do the same command and do this point cloud projection, and the results can be something like this. So like in the background, you will see this raster image of the point cloud, and then you will see the traditional section generation that we have with the automatic tagging, with the layers and the hatches and so on. Of course, these are just default options that I've just used right here, but you can customize all these lines and all these tags yourself. So this is another example how you can actually use this command to create nice 2D documentation out of it. So I hope that I gave you some more insight to our point cloud tools in BricsCAD. Of course, this is just the beginning of our scan to BIM concept, and we already started our development for the future improvements for the point cloud tools that we have in BricsCAD. So any feedback is welcome through our support ticket system, and thank you for listening.